Hi, my name is Cameron Burke, and this video is going to teach you how to identify and recognize each piece of a nucleophilic acyl substitution reaction. A nucleophilic acyl substitution reaction is a type of substitution in which the leaving group of an acyl moiety is substituted for a nucleophile. As a quick refresher from earlier videos, a moiety means a piece or a part, and an acyl moiety is part of a compound consisting of a carbonyl group and an R group. The best way to learn how to identify the parts of a nucleophilic acyl substitution is to actually look at a nucleophilic acyl substitution. So I'll come back to these bullet points at the end of the video once you understand what's going on. But before I introduce how to identify a nucleophilic acyl substitution reaction, I want to briefly touch on why it's important that you're able to do so. You want to be able to recognize a nucleophilic acyl substitution when it crosses your path, because nucleophilic acyl substitution is the major reaction that carbonyl derivatives undergo, which means that a lot of different reactions are using the same mechanism, and you get a lot of bang for your buck if you can learn that content and recognize what the mechanism is. Exactly how the mechanism in this reaction works will be explained in future videos, but for right now, the main thing you should focus on is how to tell that you're looking at a nucleophilic acyl substitution in the first place. Every nucleophilic acyl substitution reaction begins with an acyl group. As mentioned earlier, the acyl group consists of an R group bound to a carbonyl group. The acyl group is the most boring part of this reaction because it doesn't really participate, so it's in exactly the same spot in the product as it is in the reactant. While the acyl group remains unchanged during the reaction, the carbonyl carbon at the center of the acyl group is a much more interesting character. The carbonyl carbon serves as an electrophile, meaning that it wants more electrons than it currently has, because the oxygen it's double bonded to is sucking all the electrons away from the carbon. In the beginning of the reaction, the carbonyl carbon is bonded to a leaving group. Leaving groups are recognizable because they're usually going to be a weak base or the conjugate of a strong acid. The last character to come on stage in the drama of a nucleophilic acyl substitution reaction is a nucleophile. You can recognize a nucleophile because it's going to have a negative charge and it's going to have a lot of electrons. And those electrons are exactly what this carbon is yearning for. I bet you can see how this story is going to end. Our boring acyl group is in exactly the same spot that it was when this reaction started. The carbonyl carbon and the nucleophile are happily bonded together. And now that the nucleophile has taken its spot, our leaving group takes the hint and does what its name suggests, which is leave. Here's the summary of these bullet points that I promised earlier. The acyl moiety is the most boring part of this reaction because it remains unchanged from the reactant to the product. The carbonyl carbon is the star of the show because it serves as the electrophile, which is what can attract a nucleophile. Any good nucleophile is eligible to attack the carbonyl carbon. The carbonyl carbon's not picky, and the leaving group is going to be exchanged in the product for the nucleophile. If you can identify the parts of a nucleophilic acyl substitution, you'll be laying fantastic groundwork for understanding the mechanisms involved in many reactions involving carbonyl groups. Thanks for watching!